Hi guys, Dave back again, G7IYK. Okay, this video is a little bit different. This is a video whereby I'm going to attempt to explain the functionality of the bootloader. This has caused confusion in the past, so I will attempt to explain what the bootloader does. It's not difficult, but if you've not come across one before, then it's it's a sort of conceptual thing. So the PIC microprocessor, which we've discussed before, is running firmware. So there's 32K of space or programmable, effectively flash memory, on board to run your firmware. And that's a program. So the question is, how do we get the program onto the PIC in the first place? Well, there's sort of two ways of doing that. During development, like when I'm actually writing the firmware for the PIC, I tend to use a programmer, which I don't happen to have handy. It's called a PIC Kit 3, about the size of a credit card, and it plugs either into here or into this header. I tend to just use the header. It's a 5-pin header. It's got power and some programming pins. There's actually only 2 pins that connect to the processor, or 3 including a reset, and then the PIC Kit, basically the PIC Kit 3 processor, or whichever programmer you're using, then programs the PIC. Brilliant. And it only takes a few seconds. That's great. Well, it's great for me, but if I was to say somebody was crazy enough to want to build this, and what I generally do is supply a pre-programmed PIC to the person that wants to build a project, so that I know when I've sent them the PIC that it's, the firmware's on it and it's all working. So that's great. So I send them a PIC, but then the chances are with something like this that is going to require some sort of firmware update. It's going to require modification or an update or an enhancement or a fix to the firmware running on the PIC. So that poses a bit of a problem, because the person I sent the PIC to, that possibly lives the other side of the world, might not have a PIC programmer, or doesn't really want to go and buy a PIC programmer just for a one-off project. So what the bootloader does is allow that person to flash the firmware on the PIC without using a dedicated PIC programmer. They can reflash it over the USB connection back here. So the bootloader sits. It doesn't have to sit, but in this particular case, what I tend to put the bootloader in the first page. That's the first K of the PIC memory. And it sits in that memory, and for the most, like at the moment, it's sitting there now. So we can see that this board is up, and we're running the magnetic loop tuning software. So at the moment, that bootloader is basically redundant. But what it does is it, when you power the board up or reset it with the reset button, the first thing that happens after reset is the bootloader actually runs, not the application. So the bootloader runs, and the bootloader I've configured it to inspect whether this center button on the rotary encoder has been pressed. So if that is not pressed, then the bootloader then just passes control to the application, and it comes up. So basically, if I switch this off and then I switch it back on again, the application runs, because the bootloader didn't see the button pressed, so it just ran the application. Now, if it does see the button pressed, then the bootloader basically takes control, and then the bootloader on the PIC forms a communication, forms communication with a PC application bootloader, which is also on the screen. So you can see we've got a PC application here called Magnetic Loop Bootloader that's running on the PC, and at the moment it's just sitting there and it's waiting for the PIC to communicate with it. So we'll do that. So what we'll do is let's assume we want to reflash our software, We would, to do that, we basically turn it off. You can either turn it off or reset it, but we'll just turn it off. I press the center button on this control knob and then switch it on. Then let go. So what's happened now is you'll notice that the what was normally my sort of infamous heartbeat LED is now sort of rapid flashing. That lets us know that the PIC is in bootloader mode. And it's formed a communication with the PC because if you notice on the bootloader PC application, the magnetic loop progress bar has gone green and the messages come up, magnetic loop PIC attached. So that's it, basically. It's now chatting with the PC. So, well, then it's really simple. Then all we have to do, so I say I've done some firmware updates or added something to the software or done something. All I've got to do is send you a file. It's called a hex file. Or it'll be magnetic loop.hex or magnetic loop version whatever .hex, and that hex file is basically the firmware for the PIC. So I have to just open that hex file here. I just happen to have it stored on this removable drive. There it is there. So I select magnetic loop control hex, open. It's got it, and then I hit program verify. So what it did is it erased the PIC. The PIC. So it actually erased the PIC. Didn't erase the bootloader because obviously that'd be slightly counterproductive. The bootloader never gets erased. The bootloader always. In fact, I could send you a PIC just with the bootloader on it, and you could just flash the firmware later. So the bootloader never gets erased because then you're stuffed. So it erased the non-bootloader section of the memory, including E squared, and then it programmed it, and then it said it was complete, and then it ran a verification where it checks what it just programmed with the hex file that you just selected, and then it's come up with a message, erase program verify complete successfully. And now you can either power cycle it or you can just hit reset device and you can reset the PIC from the bootloader. So if I hit that, voila. So the because I wasn't pressing the button, it's running an application. That's the application we just flashed. So just to show that you can do it the other way. So if I hold the reset button and this button at the same time and then release the reset button, we also go into PIC programming mode. We've still got the display up because the bootloader knows nothing about that. So the bootloader doesn't know that there's an LCD. It doesn't care that there's an LCD connected. So it's just left, with the screen. But we go through the same process. We just go open hex file, open the hex, come here mouse, open, program verify, erased it, programmed it, right, done it, reset it. Now the screen, sometimes that happens, just reset it again. It got a bit upset during the reset cycle. There we go. So yeah, that's it, bootloader. So I always include a bootloader. The only downside to the bootloader in this particular case was I was very tight on memory for this project. I used up almost all the memory in the PIC, literally within a few hundred bytes to spare. And the only downside to a bootloader, especially on a small device like this, is it uses 1K of the 32K you've got available. So yeah, I wouldn't have been so tight for space if I hadn't used the bootloader, because I could have used the memory that the bootloader took up. Anyway, so yeah, that's about the size of it. So yeah, thanks for watching. Cheers.